Hello, everyone. Welcome to the latest edition of our JACR Journal Club. My name is Amy Patel. I'm the Associate Editor of Digital Media for the Journal of the American College of Radiology. Today, I'm really excited because we have three just very prolific experts here to talk about statistics. This is a topic that we have not explored yet via our JCR Journal Club series or really anywhere along the digital channels that we have in the journal. So I'm really excited that we're going to bring to you the Statistics Bootcamp learning particularly how the sausage is made when it comes to statistical analysis and how this team is involved, particularly at the journal. But first, before we dive in to the meat of our discussion, I wanted each of our esteemed panelists to introduce themselves. So with that, why don't we have Jon go first?
Yeah, sure. Thanks, Amy, and hi, everyone. I'm Jon Steingrimsson. I'm an associate professor of biostatistics at Brown University. I have been here since 2017, and I'm also the associate statistical editor at JACR. I think I was the first sort of statistical AE at the journal. So we had to figure things out a little bit, statistical guidelines to help authors and so on. And my background is somewhat traditional for a biostatistician. I started out liking math, did math for my undergrad. Then I got more and more applied over time, did a PhD in statistics, and then since then been doing sort of biostatistics.
Awesome. Well, thank you for being here today and for sharing your very precious time with us. We really appreciate it. How about Grayson?
Hi, I'm Grayson Baird. I'm also at Brown. I'm at the medical school. I'm an associate professor of radiology. I'm also the vice chair of research for that department. I started out as a cognitive scientist and really became curious of decision science and those sorts of things. And that led me to get a master's in pure statistics. And ultimately, I decided to go into psychometrics for my PhD, though I don't get to do that very much anymore. And I'm the statistical editor for AJR, and I'm a statistical consultant to the editor for the radiology journals. And I've been here since 2013.
Wow.
Thank you.
Amazing. Thank you for being here. And then finally, Isaac.
Hi there. My name is Isaac Jenkins. I'm a master's level statistician. I work at the Fred Hutchinson Cancer Center in Seattle. I've been there since 2015. I work closely with the PhD faculty members. They devise the plan and I implement the plan. Big into computational biology and R and high dimensional data and high performance computing. That's about it. I help the journal, the JACR, out with statistical reviews before articles are published.
Yes, thank you so much and for your time tonight and also for the journal. We really appreciate it. So, all right. So with those introductions and a little background from each of you, we'll dive into the first question. So the first question that I have is specifically for Jon. What are some common analysis errors that you see when, for example, like somebody like me who isn't an expert in this realm submits a manuscript to you to review?
Yeah, no, thank you. I mean, there's a relatively long list for sure that you see frequently, to be completely honest. And we can go through the list. I'm sure Grayson and Isaac have additional things to discuss. I mean, one thing we see pretty often is failing to account for correlations. So this kind of occurs when the analysis treats observations as independent, even though they are related. Like you might have the same radiologist read a few images, so there is sort of association within radiologists. You might have repeated measures over time. You might have clustering if it's within an hospital or however the clustering arises. And sort of what that means is that you have correlated observations. Like images that are read by the same radiologist are likely correlated, or the outcome of those readings. And so treating them as independent will usually underestimate the variability. And hence, if you do that, you get anti-conservative results, meaning that you are getting inflated type 1 errors and you sort of are not controlling the things we typically like to control. And there are very well-established methods to deal with correlated observations, like standard methods are generalized estimating equations or generalized linear mixed effects models. So there are well-established methods to deal with it that I think sort of people often neglect to implement. I don't know if you want me to go on my list or let the others.
Yeah, no. Are there any other common things that you see? And then I'll kick it to the other two panelists.
Yeah, I mean, I think this is a little more of a difficult problem, but sort of lack of consideration of who gets into your analysis set is also a pretty common problem. Like for some reason, like sicker people might be getting into your analysis set, or healthier people, or whatever it is. So you have overrepresentation of certain type of individuals, and that leads to sort of the generalizability of the study results being pretty hard to sort of, you don't know within what population you should be sort of interpreting the results with. Like if you have selection biases, it's very hard to understand sort of how, within the context of what population I'm interpreting the results within. Mm. And then a pretty common one I see, especially when we are talking about machine learning, is failing to sort of add measures of variability. Like reporting only point estimates like AUC of 0.9 without sort of telling us anything about the variability in that estimate. And I think sort of people are very used to thinking about sort of variability when they're estimating other effects like odds ratios or like differences in means or something like that. I think it comes very naturally to add 95% confidence intervals or so on. But when people are dealing with measures of diagnostic accuracy or predictive accuracy, that seems to be sort of less established. You're way more likely to see people just say the sensitivity is 68%, specificity is 95%, without augmenting that with any measures of variability. And to be honest, I think it's always a good idea to add measures of variability. I think that's almost sort of a universal principle that should be applied. And then there are also things like ignoring missing data and dropout, doing complete case analysis, or sort of dropping observations that don't have complete sort of informations on them, which are relatively common. And again, there are well-established methods to deal with both missing data and dropout. So sort of you don't want software, like widely available software to deal with these things. And then there are p-hacking. I think you see that quite a bit, even though it's a little bit hard to identify sometimes, but that's when people do a ton of analysis and then just pick the one that looks the best and report that without really sort of reporting the rest of the analysis, which makes it pretty hard to understand sort of the robustness and reliability of it. Like if you do that analysis and only that analysis, that's usually a pretty robust result. But if you have done 100 analyses and then pick the best one, that's likely to be unreproducible. And the robustness of that is pretty low. And this is going to inflate things like type 1 error and, like I said before, reproducibility of the whole result. And then in clinical trials, what I see pretty frequently is sort of failing to follow the statistical analysis plan. Like usually when you have a trial, you have a protocol that details a statistical analysis plan that has a pre-specified ways to do the analysis, and then sort of failure to do that and report that. I think, in my opinion, the primary analysis or the primary result of the clinical trial would be basically what is written down as the primary objective in the protocol. And that's sort of what should be presented, not some exploratory analysis that found something that you'd like to see. And then lastly, I think this is getting better and better over time, but I think failure to do sort of proper validation, especially in machine learning, sort of leakage between the training set and the test set. Like, for example, if you have repeated observations per participant, if you have some observation for participant A in the training set and some in the test set, that leads to sort of leakage or sort of non-independence between the two data sets. So I think it's important to sort of follow sort of standard, well-established principles for how to do that sort of validation of these models. So yeah, I think I'll stop here to see. I'm sure others have other thoughts.
You took all the good ones.
Yeah, anything from either of you, Isaac or Grayson?
Yeah, I was just gonna say multiplicity adjustments. I'm frequently, you don't have to do it, but if you're not going to do it, you should say you're not going to do it, so that the reader knows that it's that it hasn't been accounted for. The fact that you ran a bunch of tests.
Yeah. Do you mind explaining what that is? Because we do have trainees that are tuning in and are just learning about all this.
Yeah. So if you run a bunch of t-tests, let's say, and you get a bunch of p-values back for, I don't know, 30, 40, 50, 1,000 things, your probability of seeing a false positive gets really bad. That alpha equals 0.05 cutoff just doesn't really apply anymore. So you need to do some sort of correction, like a Bonferroni correction, at the simplest, to narrow down those things you're calling significant to what's probably actually significant. I think hopefully that's a simple enough explanation without getting too much into the nitty-gritty. But a lot of analyses are exploratory, and maybe you want to talk about things that are interesting. I tend to steer away from the significant descriptor and try to talk about things that are interesting. So if you're not going to adjust, that's fine. Just say you're not going to, but sort of ease back on the significant wording in your language. That would be my suggestion there. The other thing I noticed, a commenter, well, the big one is the dependency structures in the data that Jon mentioned about repeated measures, or the same radiologist interpreting something, those sorts of things. And then missing data. Sometimes missing data flies under the radar. I'll be assessing somebody's analysis, and I can tell from the table 1 or some supplemental table or something that it wasn't a complete case. The data is not complete on every single case, and so it was narrowed down to a complete case analysis, but that was never mentioned anywhere in the methods. So with that in mind, just methods in general, I look to, can I reproduce this? If you handed me the data, could I get to that result table you're displaying? And if I couldn't, then it's well, there was missing observations, and what did you do to account for that? So just a general, the person reading it should be able to reproduce it. That's easier said than done, though. As I've published a lot of papers, and the more technical something is, the more little knobs there are to tune in your analysis, and it's hard to capture that in a paragraph. So a supplemental explanation is encouraged, even including code. I would encourage that if at all possible. So I think that's what I'd like to add to that.
And I think it with medicine, oftentimes the degrees of freedom aren't reported. In other fields they are, and so it's easier to detect that if those degrees of freedom are reported, but they're not oftentimes. It's just the p-value. So I would add to those that so often analyses are done assuming a normal distribution, or the general linear model, and it's not normally distributed data. So it's count data, or it's log normal data, things of that nature. And so that I see a lot. And then when you have an interaction effect question, so let's say it's hypothesized that you're looking at the relationship between two things, but you want to know about how they differ in two groups, let's say, just to make it or maybe two different rates of change or whatnot. Oftentimes, people won't run an interaction effect. They will run the analysis separately, or they'll just put in covariates and things of that nature. And so I see those are my pet peeves. And oftentimes you see folks putting standard error bars on their figures. And to a degree, fine, but that should not be confused with a 95% confidence interval. That should be a 68% confidence interval. And I don't know why we don't, at best, and I don't know why we don't draw attention to that and be forthright in that. Those are some of my pet peeves, along with the violation of IID, which I think is the most prevalent that we probably see, is just not accounting for clustering repeated measures, even hospital effects. We have 2 hospitals and we're just slamming the data together as if they're the same hospital and whatnot, things of that nature.
Do you ever come across a situation where a manuscript submitted for you to review and there's almost too much statistical analysis where you are telling the authors to cut back on the amount of data that they have submitted and analyses?
I don't think so. I don't.
I haven't.
I don't think so. It's.
I think it's a little more about having a clean message.
Okay.
In some sense, I think you want the manuscript to have a pretty clear message. And if you're doing 100 analysis and your result section is just result after result after result without any interpretation of how meaningful these results are and how they're to be sort of how clinically meaningful they are, I think that's sort of, I think that's a situation where you can't have too many things.
Yeah, I am asking from experience because we just submitted a manuscript a few months ago to a journal that isn't affiliated with you guys. And that was kind of one of the pieces of feedback we got. So we're going to revise and resubmit. So I was just curious for my own edification if you ever kind of come across of that. And I think Jon probably explained that well, that it has to have a clear message. And if you have all this, jarbled analyses that you're submitting, it's like, and if it doesn't reflect the true nature of the manuscript, it's, the message is going to be lost. And obviously that's going to be a poor manuscript to publish. So thank you for your thoughts on that. I was just curious.
Yeah,
so.
Also, I think a lot of analysis is often a sign that people are scrambling to find that message. Like if the original hypothesis is planned out as they expected, they have a clear story to tell. But if that doesn't play out as they want it, I think you get into a situation where you're doing additional analysis, and sort of, I think this is often a consequence of that. Not always for sure, but I think this type of a lot of results are a consequence of that.
Which leads to the p-hacking you mentioned earlier, because there's just, it's hard then to convey that you did all of that in the short space that you have in the manuscript.
And then your false discovery rate just climbs and climbs. And so.
Yeah. All right. Well, I'm going to shift gears a little bit, although you've kind of touched on it a little bit in the first question that I posed. But I will kick this one to Grayson to kick us off. What are some common interpretation errors that maybe we haven't discussed yet?
So this is my pet peeve, I think, more than anything. So I'll start out by reporting p-values that are 0 or 1, which would be a probability of 100% or 0, which are certainties, or a p-value less than 0, which is a negative probability, which I think for these purposes isn't possible. Maybe the physicists have an idea of that. The other things that I've got a whole list actually. Going back to the hypotheses. So, state your hypothesis clearly, but oftentimes the research question is given as the hypothesis. So we're looking for a relationship, and we hypothesize there's a relationship. Well, that's a research question. Is there, does MRI detect cancer, but better than something else? So that's where, to be specific in the hypothesis, is it a testable question? And then in the discussion, going back to this clarity of the analysis, are we saying, did we confirm that hypothesis or did we fail to confirm the hypothesis? but oftentimes there's a bit of a bait and switch, I think. Confusing the population with the sample is another. We observe the population. It's like, well, then take away the p-values because there's no inference and confidence intervals. Using causal language is one that, for studies that don't have any experimental design. So it's just correlation. And so this improved that. And then interpreting a null result, so it's not significant, let's say, as evidence of no difference. So rather than failure of no difference to detect a difference. So that's a very nuanced thing. I have a background in epistemology, and so this is in particular, it's absence of evidence. It's not evidence of absence, basically. So if you want to show evidence of no difference, then that's a non-inferiority or a equivalence test that has its own framework. But failing to find a difference, I think we see that a lot. I don't want to take all of them. I think the last one is using the word prove, that this analysis proves something. And it's analyses show evidence for something, or they fail to show evidence for something, but they don't prove. That's a language that's special to mathematics and logic, I would say, in more determinate systems.
Either one of you want to chime in on that?
Sure. I think, I guess this isn't maybe happen too often, but interpreting effect sizes, I think I've seen some analyses come through where, I don't know, they sampled a large number of studies, cases, and so it's easy to get a low p-value when you have a large sample size, and the effect size, is so marginal. Mm-hmm. But the authors will go on to discuss it as if it is, even if they're using the correct language, it just kind of has a tone of this is a big deal, and you look at it and you go, is it that seems like a pretty marginal effect there and not helping? Does that really matter? So I think it's good to question when you find something, is the effect size actually meaningful, or is this just a tiny effect that was driven by sample size? That's all I got.
Yeah, I think they have hit big points here. I think we often see, I think what Isaac has mentioned, that clinical significance becomes a lot more important when you have large sample sizes. We have more and more of these papers who are analyzing huge electronic health records where everything is significant. Mm-hmm. Another sort of pet peeve of mine is limitation sections that just say, or that are not really honest. Like every study has a limitation. There are a lot of limitation sections are written like, this could be a limitation, but it's not a limitation in our study because of A, B, and C. And that's the whole limitation section, is sort of almost saying we have no limitations, which I don't think is true of any study. And then going back to the sort of causation versus association, I think people are very aware of this issue. And you often see the results section being very sort of good about this. But then, like saying association between A and B when they report sort of estimates. But then when it goes to the discussion section, then they use causal language like A impacts B, A reduces B, or something like that. Or go on to say implementing this program may lead to improvements. So I think sort of that's I think where the problem is kind of slipping in. It's more in the interpretation of the results rather than in the language used to sort of frame the results. Yeah, and I think that's pretty much the end of my list.
I would add, going back to effect sizes, odds ratios in particular, you'll have folks comparing odds ratios, but if they're on different scales, they're not comparable. And so you see, this is massive. It's, an odds ratio of 4, and this is tiny. And it's like, but that's based on the scale. And so, if you broke down something in yards and feet, for example, you would get a difference. And so it isn't different. Others that I see saying that because two confidence intervals overlap each other, they're not statistically significant. You see that with interpretation. And then going back to the comment about a large effect size or something, oftentimes you'll see we used a rigorous method, or we robustly, like just report what you did and let the readership decide if it's rigorous or robust, or large, those are a few of my other pet peeves.
Yeah, on a related note, I think it's becoming more prevalent to use HEDS terms, like trending towards significance or borderline significant, to sort of describe non-significant results as significant, but you never see it in the other direction. You never see significant results being described as trending towards not significant. So I think that is also something sort of you frequently see that I don't think is proper terminology.
You can't go wrong with just saying an interesting trend.
And another thing that is more like an analysis thing that I think is somewhat underappreciated and we see all the time is just something is reported in table 1 as 17.6%, but then if you read the manuscript, it's 19.6. Sort of these very basic copy-paste errors. Yeah. Or even in a table where you have a list side of, I know you have two categories and one is 50.4 and the other one is 48.6. They don't add up to 100. Sort of very basic errors that I think we see all the time when we are reviewing papers that are, I think, just easy to detect. It takes some time to go over the manuscript to sort of make sure everything is consistent. But they sort of also, they reduce your faith in the result if you see a lot of these type of very basic errors.
A lot of times that's the result of missing data, and that'll clue me in that, oh, something was done here. Somebody was removed from an analysis. And so otherwise this would have added up to 100%.
Well, when you speak about hedging, it's just like, true radiologist fashion, hedging in a report. No, I'm kidding. Just when you said hedging, I was like, well, we're radiologists. What do you expect? No, I'm kidding. Yeah, but very, very good point, and actually really good advice, even for me as I write a manuscript. I don't want to use these terms that are kind of overinflating, just state the facts and move on. So I really appreciate that guidance and advice, just on a personal level. So the next question I have for you all, I'll kick it to Isaac first. What advice would you give to people when working with statisticians?
That's a tough one. So I see myself, I'm not technically a statistical consultant, but as a master's level statistician, I meet with lots of clinicians, and they'll come in and very technical in their field, and I'm not technical in that field. So they'll come in and start talking about hearts and lungs and livers and all these things, and I'm not a physician. I think I took one biology class in college. So first things first is remember you're talking to someone that doesn't necessarily understand your science. So kind of the nice thing to first say to somebody is, can you teach me about your science? Teach me a little bit about your science. And some clinicians are really good at breaking it down in such a way that I can understand. The better I can understand, the better I can direct you towards a solution. The next thing I would say is trust the statistician. I think a lot of times researchers, they know what they want to find. They come in with a preconceived idea. They collected the data. They had a hypothesis, and they know what they want to find. But sometimes that just doesn't show up. And then try this and try this and try. And there's all of a sudden they're tweaking little things and tuning little knobs, and at some point, the statistician has to go, okay, look, we're not doing science anymore. Now we're searching. All right, we're throwing stuff on the wall and seeing what sticks. So I don't know if that's good advice, but trust your statistician and listen to him. I guess the last thing I would say is do see a statistician. Some of the most dangerous researchers I've worked with, clinicians I've worked with, are the ones that know a little bit of R. They know a little bit of Python. And this may segue into other things, but they ask the AI to write them some code, and it's easy to get it to run, and it's easy to get it to spit out a table. But as you guys know, there's a big difference between type 1 sum of squares and type 3 sum of squares that SAS created for people. And if you don't know the difference between those things, you don't necessarily know what you're interpreting. The way you entered the variables into the equation might affect the way you interpret the variables. So do meet with a statistician, and don't think that you just know how to do it and you just need to get someone to write off on it. I think it pays to have someone do your analysis, not necessarily for you, but with you.
Anyone else?
Sure. I mean, I would say the key thing is to involve a statistician early in the process. I would say the design of the study is probably the most important component. Like if you screw up the design, you're kind of screwed. Like there's not much you can do. If you screw up the analysis, reanalysis is possible. And I think the best studies have good design. And if you have a good design, often a simple analysis will get you the correct answer. And it's usually, I mean, badly designed studies will need complex analysis that usually are worse than well-designed studies with simple analysis. Obviously, you can have well-designed studies, but there is confounding or some biases that you need to adjust for independently of how well you design the study. But I think involving statistician early on and sort of making sure that you have thought through the whole thing with the statistician at the design stage before any data is collected or any major decisions are made.
So I would agree with that fully. Early and often, like voting, and I would say that it's the design, it's the measurement, it's the sampling, and the earlier we are involved, the easier your life will be in doing the study, because for us, we don't have to imagine, or we can imagine what the end looks like, how it's going to be analyzed. It's not vague or abstract to us. We know exactly. So we kind of know how it's going to end, so to speak. I mean, we don't know the results, obviously, but we know how this is going to have to be analyzed. And it's a bit like Groundhog Day, because we just have seen this again and again. And so, there's some really elegant design, measurement, sampling techniques that we can implement that will only improve the strength of your study. So, and the thing I would say is in data collection, whether you've met with us or not, is that this notion where if you find a mistake in your data and we have finished analyzing it, then we have to start over. And so those aren't hours we'll ever get back again. And so we might not have to write the code again, but we have to do the analysis, do the interpretation. And so being mindful of that we're not just putting in numbers and cranking them out.
Yeah, I might add to that just if that were to happen, or if the data updates, this is maybe more of a frustrating thing, but column names when you're writing your data, don't change column names. If you're going to give me a new spreadsheet or whatever with the corrected data, don't change the column names and all the other stuff, because it becomes then it does take us longer to rewrite the code maybe, or it does create hassles that are unnecessary. So consistency in how you collect your data, I think, is good advice for someone working with a statistician.
Yeah, and then lastly from my end, you go ahead, Grayson.
Oh, sorry. I was just going to say, and don't come at the 11th hour right before you have a grant deadline tomorrow.
That's never going to stop. That's not the fight that you want.
Yeah, I also think it's important that statisticians are like treated as sort of key members of an interdisciplinary team. Like they need to be at the table when key decisions are made, not just afterwards you tell we decided to run a t-test here. I think that's also like, yeah, I wouldn't work with people unless that condition was met.
Yeah, and it's been so long for me that's a given, but that's a great thing to mention, because, and especially in the design phase, because you might make a decision for a design that has a good practical reason clinically, but it might be disastrous in terms of experimentally. And so we at least have to be able to warn you about the consequences of certain decisions.
And I think this is even getting more and more important when people are getting into health records that have all kind of like quirky things and biases and difficulties with pretty much like they are very appealing, they are large, they are representative of real world data, but sort of all the challenges that come with it are, yeah, they are non-trivial for sure.
Well, that's great advice, and I appreciate all of you sharing your insights and your advice on that. We kind of touched on it. Isaac kind of started touching on it. The next topic, but my next question, I guess I'll go back to Jon, is how do you think AI has changed your job or changed the job of a statistician? And then I guess another question I want to add to it is like, where do you see AI sort of changing your job in the future?
Yeah, I mean, that's a big question, and it's still early on, and more changes are coming that I think are pretty hard to predict how things are going to evolve, to be completely transparent. But I think I'm hoping it means we can spend more time on critical thinking and less time on kind of mechanistical doing. Like AI, hopefully over time will be able to do analysis for us. If we say, use this data set with these variables, give them a data dictionary, give them analysis plan, detailed analysis plan, and hopefully over time it will be able to spit out reliable results. I don't know if that's doable now or not, but sort of those, I'm hopeful that AI could be helped to sort of streamline and make these things more efficient. And sort of, yeah, basically, give us more time to focus on critical thinking. And I think one thing AI cannot do now is sort of understanding data quality, understanding where the data comes from, how that sampling or how data collection or where the data comes from, impact analysis and interpretation. I think those are still things that need critical thinking and sort of good understanding of how the data arrived here. That AI is not going to know unless you tell it.
And to add to that, if it could do our more bureaucratic things as well. I think we spent so much time not doing statistics and critical thinking and design planning and things like that. We just spend so much time on mechanistic stuff, but just paperwork and things like that, and bio sketches. And so anything that could get us more time doing what we're trained to do, I think is what.
Any other thoughts?
Just it's scary that AI could put us out of a job, not from the sense that it could do our job correctly, but the sense that people think it's doing our job correctly. And that's there is some things, the sampling is a good example of some higher level thinking that unless you tell the AI about the biases in your sample, it probably just assumes they're not biased. So piggyback on that answer.
Yeah, I mean, I personally at this point would be terrified to just leave it all to an AI algorithm and not collaborate with a human. On the clinical side, I've been utilizing an AI algorithm for breast ultrasound in particular since 2019. And even though it's been a number of years, there's no way I'd let that thing, run, solitarily without physician oversight. And obviously we're still early on, but we've had a number of years, and so I can't fathom at this point that I would just look to using an algorithm to help me with that and not an actual expert human that has that knowledge and statistics and making sure that the analysis is correct. So it's very interesting to see that how it's sort of affecting your world as well. So with that, we'll shift on. We kind of, I think we've highlighted this quite a bit tonight. But if there's anything else that you wanted to add specifically, why do you think working? And obviously, we just talked about AI, and that would be a reason. But why do you think working with a statistician is so important in general?
I mean, I think we have sort of highlighted a lot of the answers here.
Yeah.
I mean, it might come off as annoying at times, like saying you're not interpreting this correctly, and we are sort of, in some sense, gatekeepers of good science to a certain degree, to use maybe a hyperbolic terminology. But I think at the end of the day, we all want to do good science, and we sort of take that job seriously, and we are there to help. Like, we are not there to stand in your way or sort of get you to get fewer significant results. So we just want to make sure that the significant results you're seeing are real. So I think, yeah. But I think all the other points have kind of been mentioned before.
Mm-hmm. Yeah, like I said, I think most of the reasons sort of were shared earlier. Another question that I have, and this is sort of an elementary question, but again, this is for some trainees that are tuning in. We really promoted it to trainees as well as they get their feet wet with this. Just a very basic question, like, let's say you have a medical student or a resident who's trying to find a collaborator in your department. Like, how do they go about even finding somebody to collaborate?
Yeah, I mean, that's a good question. I think in some sense there is more demand than supply for statisticians. I think at least that's the case at my institution, and I think so it can be tough to get a hold of a statistician for sure. And I don't have a template for an email that will sort of cure that in a sense. But I think showing interest in sort of a longer term collaboration, building some, I think statisticians like to work with the same team for a long time. Like, that builds up trust, it builds up relationship, it builds up domain knowledge on the biostatistician side, and sort of it makes everything smoother in some sense. So I think sort of approaching them not as a consultant, can you run a PT test for me, but more as a sort of, you will become a key member of this project, and we would appreciate your input. And sort of, like I said before, don't come to us and tell us to sort of to take out the fire. Come to us earlier, like, we are starting this project and we would appreciate your feedback and input and sort of and your experience here. But again, like I said before, there is more demand than there is supply, so sort of statisticians tend to be pretty selective about sort of what they work with. But if you have a mentor that has a good relationship with a statistician, obviously having them reach out on your behalf and sort of watch for you is one option. But yeah. I mostly work in a lot sort of clinical trials groups, so sort of people come to me through that group.
Mhm.
So, and if you come to me through that group, I will work with you. Otherwise, most likely I won't have time in some sense. So my situation is unique in that regard, but I don't know if Grayson and Isaac have any other thoughts.
I work at a fairly established center. We have a lot of statisticians at Fred Hutch. We have statisticians that are, they're doing their statistical research, but I work in a clinical biostats group where we're attached directly to the clinical research division. And I've been there for over 10 years now. And so much like I was saying, I have relationships I built up over time and that I'll collaborate with people that I've worked with for years now. And I've gotten to learn their particular science and their particular style of working. And so a bit spoiled. I think our institution is a bit spoiled. We have good statistical support. So it's just always the way it's been. So I don't know if I have a lot to add to that.
So I started at 50% radiology, 50% rest of the hospital. And over time, which was both good and bad, I really got to learn all the areas. But over time, I migrated over to radiology and I became full-time in radiology. So I'm a unique situation because I'm dedicated to an entire department. However, I actually don't do much statistics anymore. Maybe about a half a day a week, maybe a full day a week, depending. I end up doing most of my own research at this point. And so, which is odd, not what I plan to do, but I still have a few folks that outside of radiology that I've worked with for years, and I will continue to do that. But for us, I think it's all about being a more collaborative member of a team rather than being a consultant, if you will, if you want to distinguish between those terms. And as Jon mentioned, you gain domain knowledge and you end up having tremendous trust. And in my case, that was the case so much that, I even became part of the department and department leadership. So that isn't something that happens very often, but I will say it really is a better model to work with the same folks and in the same areas. And you can really go far in doing that because you're not having to relearn things or learn new things constantly. You can, in terms of the content area. So it's efficient.
This is great advice. And sorry.
One more quick point.
Yeah, of course.
I think it's also important for people who work with statistician to understand our incentives. And incentives differ between people, but like for a faculty member in biostatistics, you have certain expectations for promotion, tenure, etc., etc. And this could be ranging from like you are expected to fund your salary at this percent, or you will expect to write methods papers. So the more you can align with those incentives, like there's an interesting methodological problem. I see you work in, I don't know, non-parametric base, and I think there's an interesting sort of methods question here that you could solve. We are writing an account application, and one of the aims could be a methodological aim that you could lead, or sort of, I think, so understanding incentives. And I think most statisticians would rather have, like, I don't know, 5 to 10 sort of solid projects that are like bigger rather than having 30 smaller projects. So I think, understanding incentives, I think, is the key takeaway from that comment.
And it's interesting because the three of us are in very different positions, actually. And so our incentives are going to be different, but it's good to know what those are.
Mm-hmm. Yeah, and that's a great point as well. And yeah, I brought up this question really because I get random emails from like trainees all over the country that are perhaps medical students or residents at institutions where they don't have really research support and they need to get some research on their CV. And so they're asking to collaborate. And it's like, and just like you all, I have bandwidth limitations as well with all the things I'm working on personally as a PI and clinical work and all that and all of that. So, I do feel for those who reach out and just don't feel like they have the opportunities at their institution. But I also question maybe they're just not, they just don't maybe know where to go to seek that help either.
I would say with not to get into the weeds, but with step one being pass fail, there is a tremendous appetite to do research now to distinguish for residency applications. And so going back to what Jon mentioned, like there, not only are the incentives not aligned, but there simply isn't enough hours in the day for us to work on all the projects. And frankly, I'm not sure radiologists have time to work on that many projects either, or any physician. And so it is a bit of, I think, a conundrum that there's a necessity, shall we say, to do research, and there aren't the resources to, address that.
Mm-hmm. All right. Well, with that, we're just checking to see if there's any other questions. I don't see any in the comments. Do we have any on X or YouTube or anything like that? Because I can't see those. Okay. So we don't have any questions. Okay. So my last question basically is for each of you. I wanted you to share just one, if you had like one takeaway you could impart when it comes to the subject we discussed tonight, just one good piece of advice to, let's say, a radiologist at any career level who is wanting to submit a manuscript, what is that takeaway message you would give to them? And we'll start with you.
I mean, I think it's involving a statistician early on in the process.
Yeah.
Or someone with statistical expertise. Like Grayson probably self-identifies. I mean, he has a degree in statistics, but you don't have to have a PhD in statistics to be an expert.
Yeah.
There's a lot of people who know a ton about statistics without having formal training, but someone who has sort of spent the hours on learning the basic and the principles and sort of getting the understanding there.
Grayson?
Same. Yeah. I mean, if they want to submit a manuscript, it's probably too late. There is a chance that the design was not horrible, and so you can take a look, but it's probably too late.
Yeah. And Isaac?
Yeah, I mean, they took the good ones. I was, as far as a takeaway, I don't know if this is a takeaway, but earlier when you asked, what's an advantage to working with a statistician, technical reproducibility, I think, is something that gets overlooked a lot. This isn't reproducibility in the sense that you get another set of data and you can show the same effects. This is technical reproducibility on that one analysis you're actually publishing. Could you actually get the same answer again if you were given the data? And I think involving a statistician, generally we write code in such a way that, yeah, there's a history of everything that was done with the data from start to finish, and that's valuable. As opposed to going into Excel and sort of circling things and dragging things, there's no record then of what you did. So a statistician gives you a record, a hard-coded record of what was done for your analysis.
Yeah, you often say like your closest collaborator is you 6 months ago. like you submitted a manuscript, you completely forgot about what you did.
Yep.
So having that, like then you get the revisions and you have to go back and sort of understand what you did and address comments, and having that record becomes extremely useful at that time point.
Yeah. And I write my code in such a way that if I'm hit by a bus, a colleague could go in and figure out.
Yeah. We write a different kind of code, right? Not production code for software, but
That's
code
right.
to remind us. And so we actually put, useful comments. Most of us, I think, useful comments, so, this email was sent on this day and it said that this didn't work. So I said that this would work. And so it really is sort of a living, breathing documentation of how your analysis evolved.
I don't quite have that level, but at least where that code is and where the data, and they can run it. So,
well,
don't sell yourself short.
Yeah, I bet. Don't sell yourself short.
Well, thank you so much for your time and expertise this evening. This was a really enlightening and fascinating discussion. This will be airing even beyond the recording tonight, and will be amongst all of our channels. And so for those that are tuning in tonight, please don't let the discussion stop here. We are very, grateful for your time this evening. And with that, we'll wrap up and have a great night. Thanks so much.
Thank you so much.
Thank you.